Okay, so it says solve these in all exercises other than the empty set. Use interval notation to express the solution and set and graph each solution on a number line. So let's do this. So we have 5x plus 11 is less than 26. We'll solve this just like a regular equation. So we're going to minus 11. 5x is less than 15. We're going to divide by 5. And now we have x is less than 3. Okay, so that's the first thing. Let's see, it says express solution sets. This isn't set builder, so this is interval notation. That's okay. And graph each. Okay, so let's graph it. So here's how I'm going to graph. We have 0 here. We have 3 here. How I do this, if x is the first position on the left, and it's by itself, obviously, which is what it should be, then I'm going to look at this. So there are 3 outcomes, or 2 different outcomes. Well, I guess technically 4, but we have less than, less than, or equal to. You have greater than, and greater than or equal to. Okay, so I'm not going to write equal to. So this one is clearly less than. And so what I'm going to do is that's a parenthesis. These ones are parentheses. Parenthesis. These ones are brackets. Sorry, this one should go this way. And this one can go this way. Okay. I don't know. It doesn't matter which way they face because it's going to change anyway. So here we go. So we have that. This looks like an arrow and it looks like it's pointing to the left. So that's how I kind of remember. We go like this. Okay. So why did I do that? Well, if you have 3, it's x is less than 3, then it's any number less than 3. And so you want any number less than 3. So 0 is less than 3. So we want the arrow facing that way. If x is your first variable, this is facing in a direction, and this is a number, you can use that trick. Okay, guys? So that trick works if that happens. So you just have to kind of get used to it. If x is on the right, though, it will not work anymore. So I'll show you what I'm talking about. So let's do the next one. So we've got 2x plus 5 is less than 17. I'm going to minus 2x. So 5 is less than 17 minus 2x. I'm going to minus 17. That's negative 12 is less than negative 2x. All right, now there is a trick. When you have to divide, when x is with a negative number and you divide or multiply, you have to flip this the other way. So this is going to be 6 is greater than x. Okay. Now, if I tried to use that trick that I just showed you, if we have 0 here, so this is technically right. If we have 0 here, we have 6 here, and I use that trick, then it would show this. When it says 6 is greater than x. So what that means is 6 should be bigger than any value you pick for x. So if you pick x as 7, that's not good because 6 is not less than 7. So you can see that this failed. Why did it fail? Because x is not in the left position. So notice this thing is pointing at x. So if we want to write x first, it points at that. And so that is what it should look like. And so this obviously doesn't, these are the same value, these are equivalent, they mean the same thing, but the graph gets messed up if you do it without x on the left. So we go like this, we draw the graph this way, and you are good to go on that. Okay. So now, back to the whole negative flipping the thing. The reason that works that way is, let's look at this again. If I have negative 2x and you have this again. Let's say we have this. there's two ways I could solve this. Let's say I don't know how to divide by negative. So what I'm going to do is I'm going to add 2x to both sides. 2x minus 12 is less than 0. Okay, that's 0. That cancels. Then I'm going to add 12. 2x is less than 12. And then I'm going to divide by 2, and x is less than 6. And so you can see I got the same answer, and I did not divide at all by a negative in this case. So what happened? I just moved it to the other side, and then they were both positive, and I didn't have to worry about it. This only happens if the x is being multiplied by a negative. So that's the only time you have to worry about it, guys. All right. So let's look at some complex ones, which are these ones. If you ever have anything like this, guys, 6 is less than x plus 3 is less than 8. Then you work from the inside out. So we're going to minus 3, minus 3, minus 3. This is 3 is less than x is less than 5. So what does that look like on a graph? Well, here's 3. Here's 5. These are parentheses, parenthesis, parenthesis. Anything in between there works. So 4 works, 4.5 works, 4.99 works, as long as it's between 3 and 5. And so let's do one more example, and I'll make this one up. So we have, let's do 10 is less than negative 3x plus 2. Let's not do 2. Actually, let's not do negative 3. Let's do negative 2. 4 is less than or equal to 25. No, not 25. Let's do 24. I just wanted to have nice solutions. So we're going to subtract 4. That is going to give us 6 is less than negative 2x is less than or equal to 20. Then I'm going to divide by negative 2. In this case, adding 2x will not work, so you just have to remember the rule. So this is negative 3 is greater than x is greater than or equal to negative 10. Now, it wouldn't make sense if I wrote negative 3 is greater than x is greater than negative 10, because negative 10 is less than negative 3. Yeah, negative 10 is less than negative 3, so it wouldn't make sense. So I'm going to rewrite this. Negative 10 is less than or equal to x is less than 3. And then we have negative 10 here, negative 3 here. So we go boom, boom, draw it. And that is your interval notation. So if you want your interval notation, negative 10, 3. And there you have it. So I hope this helps, guys. Make sure you're practicing with Alex. Make sure you try the student practice. There was quadratic equations on the other one if you needed to, or if you wanted to practice some. But make sure you're getting the practice you need. Factoring and solving quadratic equations is probably one of the more challenging things you're going to do right in the beginning of the class. So make sure you get practice with it. Thank you.